Graphing quadratic functions. All right, so quadratic functions, quadratic functions make parabolas, P-A-R-A-B-O-L-A-S, parabolas, okay? They look like this. I remember drawing those shapes in Algebra 1 maybe, graphing some equations that had those shapes. Any quadratic function, no matter what form the equation is in, there's three different forms we're going to deal with. There is a leading coefficient that's A, and no matter which form, that A is there. If A is greater than 0, what kind of number is it? If it's greater than 0. Positive. Yeah, that's right. It's a positive number. Okay. If the number in front is positive, it's going to open up like this. It's going to look like that. It's going to be moved around. It may be wider, maybe skinnier, but it's going to resemble that shape. Okay. It's going to open up. Okay. We call that opening up. All right. If A is less than 0, then it's going to look like this. It's going to open down. So if A is less than 0, it's a negative number. It's going to open down. It's going to resemble this picture. It may be skinnier, it may be wider, it may be moved left, right, that sort of thing. But it's going to resemble that shape when we graph that. So no matter what form we're dealing with, the A that's in that form, it's deciding up or down which way it opens the same way for every form. Okay, so when we talk about vertex form, standard form, or intercept form, all three of those, that same A does all the same things. So you don't have to know three different things for that. It's all the same. Okay, now, so no matter what form, that carries throughout. The first form we're going to talk about is the one that you dealt with the most in Algebra 1, and that was standard form. The standard form for a quadratic. And this is the form that we dealt with when we were solving quadratics, when we wanted to do something with quadratic formula. It's that same form. So standard form is f of x is equal to ax squared plus bx plus c. That's the same standard form that we dealt with when we were solving. That hasn't changed. Okay, hasn't changed at all. Okay, when you're dealing with standard form, there are some things that we want to find for the graph of a quadratic. The first thing that we want to find is called the axis of symmetry. Okay, axis of symmetry. To find the axis of symmetry, it is the equation x equals negative b divided by 2a. Whatever's in front of x, take the opposite of it, divided by 2 times a, and that's going to give you x equals a number, and that's going to be the axis of symmetry. Okay, and it's an imaginary line. Axis of symmetry for any of these parabolas, it's this imaginary line that cuts right down through the middle of those parabolas. And what you could do is you could fold those parabolas along that line, and they would match up side to side. That's what symmetry is. We talked about that in geometry. That symmetry is you could fold it, and it matches up perfectly. So that's what an axis of symmetry does. We also, when we do this, it ends up giving us the second thing, part of the second thing we look for, and that's called the vertex. And the vertex is an ordered pair. The x value of the vertex is the same thing that we got when we did the axis of symmetry. Negative b over 2a. It's the same number. Okay. The y value of the vertex is taking that number and plugging it in and working it out. We're going to get a y value out of that. Okay. So vertex on a parabola, the vertex is the number that's at the bottom. If it's opening up, it's at that point right there at the bottom. That's the vertex. If it opens down, It's the point at the top. Okay. The vertex can be a maximum or a minimum. Okay. We could describe it as a maximum or minimum. If it's at the bottom, which one do you think it would be called? Minimum. If it's at the top, it's a maximum. Okay. Tie those together based on the vertex. All of that's decided by the value of A. If A is positive, we're going to have a minimum because it's going to open up. If A is negative, it's going to open down, so we'll have a maximum right there at the top. Okay, so maxes and minimums, or maximums and minimums, coming from the vertex. That point is the maximum or minimum point of the parabola. Okay. Now, one of the things, what we found when we were solving these quadratics with the last test, when we were solving, we were actually finding the x-intercepts. So we set the problem equal to 0 and solve. You're just going to take ax squared plus bx plus c. It's going to have numbers in the place. We'll do an example in just a second with this. We're going to set it equal to 0 and solve it. What options do we have in order to solve a quadratic? Factoring is one option. Square roots is an option. And quadratic formula. We got 3 options that we could use there. Factoring doesn't always work. Square roots isn't always an option. Quadratic formula always works. Okay? I don't care which way you do it. So I can test, I didn't care which way you solved any of those problems on that test. Be able to get the x-intercepts by solving that equation. Okay? So we got to still be able to solve quadratics. We hadn't moved past that. You won't move past that for a long time. It kind of comes up in everything we do from here on out. So the fourth thing that we're going to find after we find the x-intercepts is an easier thing when it's in standard form, and that's the y-intercept. The y-intercept, what's the x value when you're on the y-axis? 0. If the x value is 0, and we plug that into the problem, a times 0 squared plus b times 0 plus c. What happens to these first 2 pieces? They're just 0, and they essentially just go away, right? And all that's left is c. So your y-intercept, if it's in standard form, you can just look at the problem and get 0c. So if it's in standard form, the y-intercept's the easiest thing, because all you got to do is look at the number that's on the end, the c. That's your y-intercept, if it's in standard form. Okay, so if you're asked about, which one of these forms is the easiest to get the y-intercept from, standard form. It's got to look like ax squared plus bx plus c. The y-intercept's super easy when it's that way. You just get the number that's on the end. That's your y-intercept. X-intercepts, not quite as easy because we got to do either factoring or quadratic formula. That's a little tougher to do. There's another form that's much easier to do that with. But this one's really good for the y-intercept. Really nice for that. And then the last thing that we will do is related directly to the graph, and that's a table. And a table is just, x values and y values. Okay. And I'm going to show you how I like for you to build the table, and I'm going to show you how to use your calculator to help you build that table instead of having to plug in a bunch of numbers and do it by hand, which is kind of not hard, but long and tedious a little bit. Okay, so things for standard form. Standard form, again, is ax squared plus bx plus c. A decides which way it opens, if it opens up or down. Then we get the axis of symmetry with this formula, negative b over 2a. You know that. To get the vertex, the x value is the same as the axis of symmetry. The y value, you just plug that number in and work it out. Okay. The x-intercepts, we set the problem equal to 0 and solve it using either factoring, square roots, or quadratic formula. Any of those methods that will work for you. And then y-intercepts are always going to be 0c. Every time it's in standard form. That's a quick thing to find. The table, we're going to build it around the vertex so that we get a nice picture of both sides of the parabola. So we're going to put the vertex in the middle of our table. Okay, and we'll do an example next and do all of these things with it so we can see what's going on. Okay, so those are the 5 things that we're going to find. It's a little more than 5, but it's 5 topics that we're going to go through there. So let's look at an example. F of x is equal to x squared plus 6x plus 9. Okay, so before I graph it, I'm going to find all of that stuff and then build the graph off of that. So the first thing I'm going to find is the axis of symmetry. And you can abbreviate, you can just write axis on that. That's the only axis that we're going to deal with. So you don't have to write out axis of symmetry every time or anything like that. And so we're going to take that formula, x equals negative b over 2a. So negative b would be negative 6.